All right, so we start with the foundations of radians and degree measure. We're going to learn about what a radian is and how to find things in radians, and then we switch and we start to do it with degrees. So we start with the parts of an angle. This is just some vocab. The bottom part of the angle would be, or the start of it, would be the initial side. The place that it ends would be the terminal side. Where those two meet is called the vertex, just like a regular angle, okay? The direction of your angle is important. So if it doesn't give it, it always goes counterclockwise. But if it does give it, you got to pay attention to where the arrow is drawn. Is it drawn up and left, like counterclockwise, or is it drawn clockwise? A positive angle is generated by going counterclockwise. So we would start at my initial side on the right-hand side of the x-axis, and then the arrow would go in the counterclockwise direction, and then this would be your terminal side. So that's a positive angle, okay? That's like around, I don't even know, like 120 degrees would be an approximation of that degree. A negative angle goes clockwise. So it starts in the same location. The initial side is still in the same location. And this time I go clockwise, and the terminal side would be underneath it. It doesn't mean it has to be in that quadrant. It can go all the way around. It just means that the arrow is going to tell you which direction, okay? So you'll see this two ways. One is, here's the angle, you tell me the degree, and then here's the degree, you show me where that angle is. Okay, a radian, by definition, is the measure of the central angle of a circle that intercepts an arc equal in length to the radius of the circle. So basically, 1 radian is as though we took our full circle and we divided it into units based on the circumference. So if you remember, circumference is all the way around the circle, right? If I had how do I find circumference? What's the formula to find circumference? Pi d or 2 pi r, right? Both the same things. So now let's say that our radius is 1, okay? If this was 1 unit long, what's the circumference of this whole circle? 2 pi, right? This would be 2 times 1 times, or 2 times pi times 1, which would be 2 pi. Okay, what do we approximate pi to be? 3.14. So if I actually approximate it to be 3.14, that means my whole circle all the way around is how much? 6.28. So this is where the measurement of a radian comes from. The full circle all the way around is 6.28 radians. So in a moment, I'll teach you how to divide that up so you can graph a radian, okay? But all the way around would be 2 pi, which is also 6.28 radians. So think about that in terms of the actual unit measure, okay? Halfway across would be what? Pi, which is what we would approximate to be like 3.14, right? So if it's asking you to graph 2 radians, you're going to use those measurements to approximate where it would go, okay? But really, what the radian measure is just as if the length was the same as with the radius being 1. If it goes, so like if you look at this, this would be 2 radians. This would be 3 radians. So in my opinion, the easiest way to do it is to go all the way around your circle. So if I draw a circle, and I start at my initial x and I go all the way around, this is 6.28 radians. We just said that, right? So halfway across here would be 3.14 radians because it's pi. So if I want to know where 2 radians is, I would actually just divide this into each whole number radian. I would say a little bit less than 3.14 would be 3. I would extend it across to get the other side. That's 6. And then I take this arc and I divide it into 2 more because there are 2 happening here. So there would be like this and this. So like a third and then 2/3. And go across with it. This would be 1 radian. This would be 4 radians. This would be 2 radians. This would be 5 radians. So it's in a total approximation, but that's how you want to do it. All the way around would be 6.28. Halfway across would be 3.14. And then go a little bit less than that. Plot your 3, go across, that's your 6. Divide the 1 to 3 into 2 other parts, and then go across with them, and that's your 4 and your 5. So if you had drawn this, and then it had asked for you to draw something that is 2.5 radians, then my initial side would be here, and I would go about halfway between these two, and this would be 2.5 radians, okay? So we are going to learn how to do all this in degrees, which is much easier because you're used to degrees. The radians is usually what people get hung up on. If you can just draw yourself that little circle and then figure out where it falls, you're better off, okay? So get to learn how to do what I just did, and it will make your life a lot easier. So if you think about, these are the 4 quadrant angles, okay, which are the foundation of what we're going to do. If I go all the way around the circle, it's 2 pi. If I go, let's go halfway. Halfway, it's pi. If I go 1/4, it'd be pi over 2 because it's half pi. And if I go 1.5 all the way around, it's 1.5 pi, which is 3 pi over 2. So eventually we're going to learn unit circle. You didn't have to learn it if you were in Algebra 2 last year because you got to use it. You won't get to use it this year, so we're going to learn how to fill in a unit circle, okay? And those are the 4 starting points for radians. 0, pi over 2 at the top, pi on the left, 3 pi over 2 at the bottom, and then 2 pi all the way back around where 0 is. All right, so this one says, draw and label each angle in standard position and state which quadrant the angle lies in. So first of all, you just want to start with your XY axis. It doesn't have to be a circle. And your initial side is always at the x-axis on the right. So if I wanted to draw that little thing is alpha. If I wanted to draw that, it's 3 pi over 2. Where's my terminal side go? Where's the end of this angle? Where's 3 pi over 2? Down at the bottom on the y. We just did that, right? Yeah? Let's go bottom. So I would go all the way around here, and I would draw the terminal side there, and I would label it, that little like Jesus fish looking thing is called alpha. It's very important in this chapter that you learn the Greek letters. It's very good college prep. When you go to fraternities and sororities, you will know how to say those letters. All right, next. That's a beta. 2 pi, where? Where's it start? Where's it stop? All the way around. So it starts here and it goes all the way around back to here. This last one is theta, 7 pi over 4. Not where I told you to put things, right? How could you figure it out? Well, first take it, convert it, right? Is that what you're doing in your head? Yeah. What's 7 over 4? 1 and 3/4. It's a good thing you didn't have a test today. All right, so 1 3/4 pi. If 1 pi is here, right, and 2 pi is here, and 1.5 pi is here, where would 1 3/4 pi be? In between these two. Yeah? I thought this is the difference between what I just showed you with the 1, 2, 3, 4, 5, 6 and these. These have pi in them. Those do not. Okay, that's the difference. They are both radians. They don't have to have a pi in them to be radian. A lot of us assume that. They just don't have a degree symbol. That's how you know the difference between degrees and radians. Okay. So if I wanted to convert this to 2 times 3.14, this would be 6.28. I could also do it that way and go all the way around my circle. I think that's harder. I think it's better to learn where your pi over 2, pi, 3 pi over 2, and 2 pi is, and then figure out if it's a mixed number, where does it fall in between which of those? 3 pi over 2 is not in a quadrant, right? It's actually on the y-axis. 2 pi is on the x-axis. And 7 pi over 4 is in the 4th quadrant. Oh, wait. Okay, coterminal angles are angles that start and stop in the same spot. So they're in standard position. They always start at the same point, and they always end at the same point, but they may go around your circle more or less times. So if I said pi, let's say, for example, that would be pi, right? If I said 3 pi, I would go all the way around the circle once, that's 2 pi, and then I'd go another pi, and I'd be back at the same spot. If I said 5 pi, if I said 7 pi, all of those are the same angle. They just go around your circle more times, okay? So 5 pi would be around twice, 2.5 times. 7 would be around 3.5 times. But these are coterminal, which means they start and stop the same way. Notice the relationship between pi and 3 pi and 5 pi and 7 pi. What's happening there? They are odd. What happens if I do 3 pi minus pi, 5 pi minus 3 pi, 7 pi minus 5 pi? 2 pi every time. So the way we find coterminal angles is by adding or subtracting 2 pi. They're called coterminal. So same start, same finish, just around more or less times. If it asked you to graph it, you would show the arrow. Yep. So this one says find 2 positive and negative angles that are coterminal to the given angle. So I'm in radians. I know that because there's no degree symbol here. So I'm going to add and subtract 2 pi. So if I wanted to find a positive coterminal angle to negative 3 pi over 4, do I add or subtract 2 pi? Add. If I wanted to find a positive, I would take and add to it. Yes? Holy crap. Plus 2 pi. I'm going to do what with this to get it to be one fraction? Same denominator, so 2 pi over 1 becomes what over 4? 8 pi over 4. And then I would do negative 3 pi over 4 plus 8 pi over 4, which is 5 pi over 4. We're getting warmer. We're doing a good job. That's the first positive coterminal angle. Now, if I want 2 positive, what do I do now? Add 2 pi again, and I already know it's 8 pi over 4. And I get 5 plus 8, 13 pi over 4, good. No, that's 2 positive coterminal angles. Then it says 2 negative coterminal angles. How do I find those? Subtract. So I'm going to take negative 3 pi over 4, and I'm going to subtract 2 pi, which we know is 8 pi over 4. And I get negative 11 pi over 4. There's 1 negative. And then I subtract again 8 pi over 4. And I get negative 19 pi over 4. So 2 positive and 2 negative. So here's what you'll see on these, which we'll get to, is that the first one starts so far negative, like this, that, and I asked for a positive one, you add 8 pi over 4 to this, and it's still negative. Does that count as a positive coterminal angle? No, you have to add again. So if it says positive, you have to add until it's positive. If it was reversed, if it was so big that when you subtracted it still wasn't negative, you have to subtract until it's negative.
So if it was like that and it was asking for 2 other negative coterminal angles, could we put that?
You sure can. Yeah, so there's multiple answers to these. So if you gave me that one, it'd be right. If you skipped that one and went to the next one, it would also still be right.
Okay.
Yeah. Usually if it wants a fixed one, it will give it to you on an interval. It'll say between negative 2 pi and positive 2 pi, give me 2 of each, and then it has to fall in that range. All right. All right, so the positive ones, we want to add 2 pi. You should have gotten 17 pi over 6 and 29 pi over 6. And then the negatives, we're going to subtract 2 pi. We got negative 7 pi over 6 and negative 19 pi over 6. Raise your hand if you got right. Oh, Lord, good. Thank you. All right. So again, remember, if it says positive, it has to be positive. I would say that's the only catch with these. It has to be positive, and if it's negative, it has to be negative. Now, if I had taken and I had plotted all 5, this one and the 4 coterminal angles on my unit circle, they should all be the exact same angle. You're just going around more times or less times, okay? That's how the coterminal angles work. All right, so we're gonna first talk about all these angles in degrees. Tomorrow, we're gonna fill in the full unit circle, and I'll teach you how to find all those angles. For right now, I just want you to identify, like, no for sure, 0 is on the right, 90's at the top, 180's on the left, 270's at the bottom, and then when we would double back around to 360 degrees here. So that's based on a full circle, which would be 360 degrees. We're gonna learn how to do this in radians too. Like you see the radians, this would be 0. Here's my 0. Here's my pi over 2. Here's my pi, and here's my 3 pi over 2, and it would double all the way back around to 2 pi. So in between each of those 4 quadrants, you're dividing that into 3 more angles. These are special angles. 30, 60, and 90 are obviously a 30, 60, 90 triangle. That's why that's special. And then 45, 45, 90 is a special triangle, and that's why that's special. And then it goes in those increments all the way around your unit circle. So again, for today, you need to understand it's 0, 90, 180, 270, 360. And the reverse of it, if it goes negative, then you've got 0, it's still in the same spot, but now this is negative 90, this is negative 180, and this is negative 270, and it would all come all the way back around to negative 360. And then in radians, this would be 0 still, then this would be negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So I would say there's 2 ways to plot a negative angle. One is draw it as though it's positive, and then fold your axis along your x-axis, and where it overlaps is the right answer. So let's just say we'll start with something like negative 30. I could start where 30 degrees is, which is in my first quadrant here. This would be a positive 30. I could, using my brain, fold this from top to bottom along the x-axis, and where it overlaps is the negative version of that angle. That's one way to do it. The other way is just to reverse your direction. So if I'm going positive 30, I'm going counterclockwise. If I'm going negative 30, I'm going clockwise, okay? The bigger the angles, the harder sometimes that is when you start to get in the second and third quadrants. People get a little bit confused in that, so maybe stick with the first, but it's completely up to you, okay, how you choose to do that. You could do either one. All right, now we're going to talk about everything we just talked about with radians, but in degrees. So if the full circle was 2 pi is the same thing as 360 degrees, and to find coterminal, we added and subtracted 2 pi. If it's in degrees, we add and subtract 360. So if I wanted to find coterminal, I added and subtracted 2 pi, right? Which is a full circle. Now it's in degrees. So instead of 2 pi, we use 360. So all the way around my circle would be 360 degrees. Yep. To get from degrees to radians, we take the angle measure and we multiply by 180 over pi. To get from radians to degrees, we take the angle measure and we multiply times 180 over pi. So it is common for a radian to have pi in it, but it doesn't have to be there. Like obviously pi over 2 is in radians, but so is 2.5. If it doesn't have a degree symbol, it is in radians. This is called degree, minute, second notation. So if you have your calculator, you want to take it out. I'm going to teach you how to do this. I'll teach you how to do it without the calculator, and I'll teach you how to do it with the calculator. Degree, minute, second notation has 3 parts to it. It has the degree, it has the minute, and it has the second. So they use this in like bearings, like if you've ever been out in the ocean and you want a coordinate and you're trying to find somewhere, like your, what's it called? Your GPS location. is based on degree, minute, second notation. Okay? So the degree is obviously the first spot. That is your whole number, whatever that is. And then your decimal is divided into two parts, minute and second. If you are going from degree, minute, second notation to decimal degree, which is just your normal decimal, then I would take whatever the minute is and I would divide it by 60 because that's how many minutes are in the hour. If I had seconds and I wanted to convert this into decimal degree, I would take the seconds and divide it by how many seconds are in an hour, which is how many? 3,600. So if I had a number like this, 31 degrees, 41 minutes, and 12 seconds, I would do this with it. I would take the 31, which is the whole number. I would take the 47 divided by 60 and the 12 divided by 360 and add all those numbers together. So do that and see if you get 31.787. You can do it all in one step if you're using a graphing utility. You just have to group it. So it would be 31 plus parentheses 47 divided by 60. Close the parentheses, plus, open the parentheses again, 12 divided by 3,600. It will divide and actually, by order of operations, you should still get the same answer. Okay. Yeah. Yeah, because it divides before it adds. You should get the same answer. So again, it would be, well, it terminates, but 31.7866666 repeated is what it should be. Everybody get that? Yes? Okay. Okay, the other way to do it is this. So if you have a graphing utility and you have a little button here that says apps and then it says angle above it, we're going to use this a lot in the next chapter, okay? You would type in 31. You would go second, apps, to bring up that angle. And you're going to grab the first thing that looks like the degree symbol. And then you're going to do 47. And you're going to go back to that same menu, second, apps. And you grab the single tick mark. And then you go 12. And I know what you're thinking. Go back to the same menu because it makes sense that it would be there. But it's not. It's over here above the plus button in green. So you hit alpha, because that's what green is. That button, not that button, that button. Dang it. It's so hard to see this. Alpha, and then plus, and then hit enter, and it will convert it for you. So why is that helpful? Because we are going to eventually do law of sines and cosines and stuff like that with decimal degree and degree, minute, second notation. And if you want to keep it exact, you will type it in just like that. So if I wanted to find the sine of that, let's just say, I would hit sine and then I would type that in exactly as it is instead of rounding it. Not all calculators have it. If you're using a scientific calculator, it just has to have some sort of an angle or a trig button, and I'm sure it's there. We could find it, okay? But for sure it's on that graphing calculator. Now let's say we want to go back the other way. Let's say I give it to you because when we get to it, when we're talking about like degrees and stuff like that in word problems, well, you'll see. If I give it to you in degree, minute, second notation, you have to give it back to me in degree, minute, second notation. So there's times when you're going to have to convert it back. To convert it back, I literally just take that number so I can pull back my answer, second answer, right? And then I go second, apps, and I get back to that angle menu and look at number 4. It says arrow DMS. I hit that and it converts it back into degree, minute, second notation, okay? So same menu, second apps, but this time we hit arrow DMS, and that tells it, put it back in degree, minute, second notation. Almost every scientific calculator has a button that does that too. Some of them are even easier because they put all the degree, the tick mark, the double tick mark all in one. So that's how we would convert from one to the other, okay? It's and the same, so second angle, or second apps, and it's the fourth thing down. Bring it in. Remember, I know the difference between radians and degrees simply based on the degree mark. If I had just 3 written there, that is 3 radians, okay? So 30 degrees to get to radians, I would multiply times pi over 180. I can cross cancel the zeros, and then 3 goes in 18 6 times, and I get pi over 6. So you want to keep this as simplified as possible. Pi over 2, now it's in radians, and I'm converting to degrees, so I put it at times 180 over pi. The pi's canceled, 2 goes into 180. 90 times, you want to make sure you put that degree symbol if it was short answer. I think on website it doesn't matter. I'll check. All right, you do the other two. Convert from degrees to radians or radians to degrees. So on the answers for website, if it's open-ended, you do have to put the degree symbol, so just be careful. Make sure you include it. All right, so 160 times pi over 180 becomes 8 pi over 9, and 3 pi over 4 times 180 over pi becomes 135 degrees. Good so far? Yes. All right, complement and supplement. Hopefully we know these words from things like geometry, okay? I mean, you should know this all the way back to elementary school, but a complement to an angle is an angle that the two add up to 90 degrees. So complement means they sum to 90 degrees. In radians, that means pi over 2, because those are interchangeable. Supplement means they sum to 180 degrees, which means if I'm trying to find it and it's in degrees, I'm going to subtract the angle from 180. If it's in radians, I'm going to subtract it from pi. In order for an angle to have a complement or a supplement, they have to both be positive. So if something is bigger than 90 degrees, it does not have a complement, or bigger than 2 pi. And if it's bigger than pi, or 180, it does not have a complement. I mean, a supplement. It has to be less than it. So like if I say what's the complement to 90 degrees, there is none.
But there would be a complement to 180?
No. No. Has to be less than. So in order for it to be a complement, it has to be less than 90 degrees or pi over 2 in radians. In order for it to have a supplement, it would have to be less than 180 degrees or less than pi. If it is those or bigger, then it does not have it. Yeah. So if you're going to write an answer and it's negative for a complement or supplement, it's wrong. It can't be negative. All right, example 4 says, find, if possible, the A complement and B supplement to each angle. So A, complement. Let's try with this one. Complement, I'm going to subtract from pi over 2. Pi over 2 minus 3 pi over 4. There's a lot of denominator changing in this chapter. Multiply by 2, well, for a while, actually, from here on out. Does this have a complement? Could I save myself a lot of work by saying this is bigger than a half pi? Yep. There is no complement. Supplement would be pi minus 3 pi over 4, which is 4 pi over 4 minus 3 pi over 4, and that's pi over 4. So there's no complement, and the supplement is pi over 4. For B, it's in degrees. Is this bigger than 90? No, so I'm going to go through the work of 90 minus 82, and I get 8 degrees. And then bigger than 180? Nope. I would go through the work, and that would be 98 degrees. So complement and supplement. All right, last thing in this section is arc length. So the length of the arc, if you remember from geometry, is like the measure of the crust of the pie. It's just the outer edge, just a portion of your circumference, okay? In geometry, we do it a little bit differently. We put it in terms of degrees. In here, we're doing this in terms of radians. So the formula is that S, which stands for the length, and don't ask me why, but it does, okay, equals R, which is the radius, times theta. Now, theta has to be in radians. So theta is the degree of the central angle which you're trying to find the arc of. It has to be in radians, and then all you have to do is multiply it times the radius, okay? So I remember it as SOR. I flipped that order, and remember it as SOR. If you want to do the same thing, that's fine. It's S equals theta times radius. And again, theta has to be in radians. That's the mistake people make here. So this says find the length of the arc. If A or 1, R is 3, and theta is 120. I'm going to do S equals theta times the radius, but theta has to be in radians. So is the theta in number 1 in radians? No, there's a degree on it, right? So we convert 120 times pi over 180. The zeros cancel. I can do 6 and 9. This is 6 pi over 9. That would be theta. This becomes 2/3. So theta is 2 pi over 3. And then 2 pi over 3 gets multiplied by the radius, which is 3. And again, we keep this exact, so the 3's get canceled, and this would be 2 pi. If it gave me a unit on the radius, I could use it. If it was centimeters, inches, whatever it is, I could use it because this is a length. 2 gives me it in a drawing. I got my central angle, which is 4 pi over 5, and I've got my radius, which is 7 centimeters. Is theta in radians this time? Yep, all you got to do is multiply it together. It doesn't simplify, so I multiply straight across, and I get 28 pi over 5. And this time it gave me a unit measurement. It's centimeters. Questions on that one? So if this is open-ended, which it would be on a quiz or a test, you're going to leave your answer like this, but on WebAssign, it says find it and round to 2 decimal places. So you'll take your calculator and literally do 28 times pi divided by 5, and that would be 17.59. So just pay attention to directions. That's like numbers 16 and 17 on WebAssign. It says to literally multiply it out and then write it with 2 decimal places. All right, last one just reverses it. So find the radius of the circle with the given information. This time I'm giving you the arc length, and theta, you give me the radius. So just plug it in and solve for r. So length of the arc would be the s. This is pi equals theta, which is 3 pi over 4, times r, and I want to solve for r. How do I do that? I could do it all in one step, multiply by 4 over 3 pi. Nope, pi would be in the bottom. Or I could separate that out. Multiply by 4, divide by pi, then divide by 3. You could do it in whatever order you want, okay? So if I do it all in one step, the pi's cancel, and I get r equals 4/3. It didn't give me a unit measurement. If it did, I would put it on there. And the last one, S is my arc length. Theta is 4 pi. Radius is what I'm missing. Again, you could just cancel out the pi's and then divide by 4. You could do it all in one step. R is 6. So just pay attention to what they give you and what they're asking for, because some people just try to take that and multiply it together, which is wrong. For the one in the homework, actually, so when you're taking your quiz or your test on this stuff, you will leave this exact. Here.